Let's begin by going over the structure of the atom as we've now understood it to be after the experiments that occurred in the latter part of the 19th century. So what we have is an atom which in fact is composed of pieces. And the pieces are of three kinds: protons and neutrons, which weigh about the same, as you can see in the chart. Protons have a positive 1 charge, that's 1.6 times 10 to the minus 19 coulombs, and neutrons are neutral. And then outside the nucleus are the electrons. The electrons have exactly the opposite charge of the proton. They have a charge of minus 1.6 times 10 to the minus 19 coulombs each. But they have almost no mass compared to the proton and the neutron. Again, it's 0.05% of the mass of a proton or a neutron. So we say that the mass of the atom is concentrated in the nucleus, which only represents about 1/10,000th of the size of the atom across. So, for example, if the nucleus were a centimeter across, that's less than half an inch across, the electron would be located about 6/10 of a mile away, or a kilometer away, which is about 6/10 of a mile. So you've got less than half an inch for the diameter of the nucleus, and half a mile for the position of the first electron. So the nucleus is very small, very, very small, and very dense, and contains virtually all the mass of the atom. Nuclei can have different numbers of protons and neutrons. The protons, which are symbolized by the letter Z, are what define what the atom is. The atom is defined by the number of protons in the nucleus. All atoms with 6 protons in the nucleus are carbon atoms. As you'll see, the protons in the nucleus have a direct effect on the electrons, and that's why the protons are a better descriptor. So the number of protons in the nucleus defines what the atom is. On the other hand, atoms with the same numbers of protons can have different numbers of neutrons. And in that situation, we have what's known as isotopes. So in this case, we have magnesium, which has 12 protons. That's what makes it magnesium. But if you count, there are also 14 neutrons, and 12 and 14 is 26. So the symbol has the abbreviation for the element. In the subscript preceding it is the atomic number. That means these two are redundant, because 12 is the atomic number for magnesium, meaning anything with 12 protons must be magnesium. But in the superscript before the symbol is the atomic mass, and this is therefore the protons plus the neutrons. So this is the isotope of magnesium that has an atomic mass of 26, because it has 12 protons and 14 neutrons. Over here we have another magnesium atom, again with 12 protons, but this time it only has 12 neutrons. That's magnesium 24. So these two then represent isotopes of the element magnesium. Same atomic number, the number 12, which makes it magnesium, but different atomic masses.